Hi guys, this is Miss Scott here. So in this video we're going to do a little reviewing for the semester final. So this is just going to be problems coming from chapter 7. To go ahead and get started here, we're going to solve this first equation for x. And we're asked to give our answer to 3 decimals. So we can do a little rounding with that. First thing we want to do is actually get the x to the power of 4 all by itself. So we'll divide by 3. Those are going to cancel, and we're left with x to the power of 4 equals 27 divided by 3, which is 9. Well, now the opposite of taking a power of 4, if you remember, is taking a fourth root. So we'll take the fourth root of both sides, and then that'll cancel, and we'll get x equals the fourth root of 9, which is the same as 9 to the power of 1/4, which is, if you plug that in a calculator, about 1.732. Okay, so what I'm going to do here in this video is work through most of these problems with you, but then I'm going to leave some problems for you to do as practice. So let's skip to, you can try that one on your own. If you'd like to pause and do it now, that's fine, or you can come back to it later. Alright, let's take a look at number 3 then. So what I have to do with the powers here, if you recall, is add them. So we're going to add the 4/3 and the 1/3, and that gives us x to the power of 5/3, and we're going to rewrite that in root form or in radical form. So if you remember, that denominator is your index, so we end up with a cubed root or a third root of x to the power of 5. Alright, so I'll give you number 4 as practice there. Let's skip ahead to number 5. So we're asked to simplify this. The first step here is that we're going to split this up into the cubed root of 27 over the cubed root of 10. Now the issue here is that we can't have any roots in the denominator. Well, in the numerator we can simplify that because the cubed root of 27 is just 3. And let's rewrite the cubed root of 10 as 10 to the power of 1/3. So what we're trying to do here is get that denominator to a whole power. We can't have any fractions. Well, if I think about what I did back in number 3, I'm trying to figure out what number that I can add to 1/3 to get just a power of 1. Well, I know that 1/3 plus 2/3 is 1, so we're going to multiply by 10 to the power of 2/3 in the denominator. And we've also got to do that in the top. So what we end up with in the bottom is 10 to the 3/3, or just 10 to the power of 1, which is 10. And in the top, we end up with 3 times 10 to the power of 2/3. Well, let's just write that as the cubed root of 10 squared. All right, and we could simplify that a little bit here. We could write the top as 3 times the cubed root of 10 squared is 100, and then that would all be over 10. Okay, so now that we don't have any roots or any fractions in the denominator, that would be our answer there. Okay, so 6 is going to be a little tricky as well, so why don't we go ahead and look at that one together also. Alright, so if you look here, we're going to start this the same way that we started number 5. We'll split this up into the square root of 16 over the square root of 8. And if you remember, the square root of 16 is just 4. And we still have the square root of 8 in the bottom. And again, that's an issue because you can't have square roots in the denominator. So we're going to multiply the top and the bottom by the square root of 8. And in the top, we get 4 times the square root of 8. And in the bottom, the square root of 8 times the square root of 8 is the square root of 64, which is just 8. Well, now there's actually something we can do right here with this square root of 8. There's a perfect square that goes into 8, so we will split this up into 4 times the square root of 4 times the square root of 2. Because 4 times 2 gives you 8. And the reason we do that is because now the square root of 4 is just 2. So we get 4 times 2 times the square root of 2 over 8. And then 4 times 2 is 8, so this will end up being 8 divided by 8, which is 1. So it turns out that this and this will cancel, and our final answer will just be the square root of 2. Okay. Let's look at one more in this section. We'll do number 7 together also. So it's kind of the same idea that we did here with this square root of 8. We are going to split this up into a perfect cube. So if you think about it, 8 is a perfect cube that goes into 16. Let's split this up then into the cube root of 8 times the cube root of 2. And we can actually take the cube root of 8, that's 2. We can't take the cube root of 2, so we'll just leave this as 2 times the cube root of 2. And that would be our simplified answer. All right, so number 8 will be pretty similar to that. I'll give you that one for practice. And then we are going to do a few examples out of this section here. So we have these two functions, 2x minus 3, and this function here, x plus 5. So we have to, in number 9, add these two functions together. Well, to add two functions together, all you're going to do here is combine like terms. So we're going to add this 2x minus 3 to this x plus 5. And notice here we have 2x plus x is 3x. And negative 3 plus 5 is a positive 2. So we end up with 3x plus 2 would be the simplified answer. All right, I'm going to give you a little hint here on number 10. So we have 2x minus 3 times x plus 5. So just as a hint here, you are going to have to distribute or FOIL this problem out, and then there should be some like terms that you can combine to get your final answer. So I'll leave those couple of steps there for you to try. All right. Now 11 and 12, we'll do those together. So that's what we call composition. And in number 11, we're going to take this g function, g of x, and put it inside of this function. So instead of having 2x minus 3, we have 2 times x plus 5 minus 3. So we're replacing the x in the first function with the second function. So to simplify this, we can go ahead and distribute that 2, and we get 2x plus 10 minus 3. And 10 minus 3 would give us 2x plus 7. All right, so that would be all our like terms are combined, and that would be our answer right there. Now 12 is almost the same, but notice here we've got negative 1 inside of the g function. So first we're going to replace both the x's with negative 1 up here, and then that is what we're going to plug in for x in the f function. So we'll have 2 times negative 1 plus 5 minus 3. And there's a few ways to solve this. You can actually solve it exactly the same way we did number 11. So we could just distribute that 2 and get negative 2 plus 10 minus 3. Negative 2 plus 10 is 8, and 8 minus 3 would give us an answer of 5. All right, let's move on to finding inverse functions. So the first step to find an inverse is to simply switch your x and y variables, and then the next few steps are just trying to get y by itself. So first, let's subtract 5 from both sides. These cancel. We end up with x minus 5 equals 2y. And now the last step we can see here to get x, or to get y by itself, would just be to divide everything by 2. So these 2's cancel out, and I'm just going to leave this as x minus 5 all over 2 equals y. So that would be the inverse function of y equals 2x plus 5. All right, so I'll leave 14 for you for some practice. And let's look at number 15 here. I'm just going to put these axes in here so you guys can see a little better what's going on in this problem. And the first step we have to take here is to actually just graph what we call the parent function. So let's make a table of x and y values here. And my parent function is just going to be this x squared portion, and then I'm going to have some shift at the end. So I'm going to choose these 4 x's because I can take the square root of those really easily. The square root of 0, the square root of 1, the square root of 4, and the square root of 9 are 0, 1, 2, and 3. And then we're going to graph those 4 points. So we got 0, 0, 1, 1, 4, 2, and 9, 3. So we end up with this graph here. But now, what's going to happen with this -4 and this +3 is that it's going to shift everything right 4 and up 3. So we're just going to walk these points over by 4 and then up 3. So there's 0, 0 now. And then if we walk this point 1, 2, 3, 4 to the right, up 3, right 4, and up 3. So this here would be our shifted graph. So this highlighted portion is the graph of this function. All right, we got one more example here to take a look at. We are going to solve a couple of root functions. So in number 17, we have to first isolate the root, meaning we've got to get this 4 over to the other side. So these cancel. We end up with the cubed root of x plus 3 equals 3. Now, if you remember, we're trying to get x by itself, so we have to get rid of this cubed root right here. And in order to do that, we're going to just cube both sides. Because the cubed root and a power of 3 cancel out, so we're just left with x plus 3 equals 3 cubed, which is 27. And if we subtract 3 from both sides, we end up with our answer, which is 24. All right. So I'll leave 18 for you for some practice. Just a hint here, this 2 is 2 times the square root of x. So your first step is going to be to subtract that 4 over, then divide by 2. So you'll be left with the square root of x equals 3. And then you can square both sides to get that x by itself. So just be careful with 18, that one's a little tricky. If you guys have any questions, feel free to find me, and I can help you out with whatever you need. Thanks for watching.